Welcome back to ATF Garage. Firstly, I'd like to thank you all for the continued and growing support. We are well on our way to hit that YouTube required 1,000 subscribers. So if you like the content, please help us out by subscribing and sharing this video. Your support really does keep this channel going. Today, we will continue our head-to-head comparison of the 225 Slant 6 and the 318 small block V8, and further explore the rivalry between these two. There has been a lot of back and forth in the comment section between which of these two would actually be faster going down the track, with many of you saying that the 318 should walk the Slant 6 in the quarter mile. So today, that's just what we're gonna do. We're going to compare the 60-foot, 0 to 60, 8th mile, 1,000-foot, and quarter mile times, as well as what speeds they hit them at, then dissect what that translates to. But before we get into that, let's do a brief introduction of these engines and shed a little light as why they became outright legends. In the early 50s, the V8 platform was an absolute battlefield, with engineers coming out with huge advancements in order to try to stay on top of its competition. One such advancement was the Chrysler dual rocker engine, or as we now call it, the original Hemi. This engine came out in 1951, exactly 70 years ago. The platform used was a 331 cubic inch V8, weighing almost 1,000 pounds and produced 180 horsepower at 4,000 RPM. Originally developed for Chrysler Aviation Research, the newly designed heads boasted opposing valves, intricate valve train utilizing dual rocker arm shafts per each cylinder, and of course their legendary hemispherical combustion chamber. This was their secret to producing an engine that was both efficient by 1950 standards and a performance powerhouse. There are three principles of airflow that determine how an engine makes power: velocity, volume, and area. The new Hemi design improved on all three. Because each valve now had a dedicated rocker arm, they could be opposing positioned to follow the airflow's natural path, increasing both intake and exhaust velocity. With a hemispherical shape, the combustion chamber roof is rounded, increasing the total available volume. And because of this rounded shape, larger valves could be fitted and canted, increasing the total usable area. However, these engines had one major Achilles heel. The cost of production was very high, so Chrysler engine developers began working on a less expensive variant. This variant was dubbed the Poly or the Semi-Hemi. This design still had a somewhat hemispherical or circular combustion chamber, but dropped the rocker arm shaft from 2 to 1 and had canted valves for a more efficient airflow. This resulted in faster production, lighter weight, and above all, lower cost. Armed with this engineering innovation, the big three, Chrysler Firepower, DeSoto Fire Dome, and Dodge Red Ram, offered some 14 different V8 variation engine packages across the Chrysler showroom floor. However, there was a lesser known Plymouth engine series called the Hi-Fire. This is where the humble beginnings of our heroes started. This series started in 1955 with the Poly 277A, gradually increasing in size and improving overall performance year by year, eventually landing on 318 cubic inches in 1957. The Poly A series engine was eventually dropped in 1967 and the new 318 LA began its historic run. The new engine package was meant to be the workhorse for Chrysler, no longer focusing on outright performance, but rather centering on low cost, longevity, and fuel economy. This was attained by replacing the Poly head with the LA one. This redesigned the combustion chamber from a polysphere to a wedge shape, changed the position of the valves from opposing to linear, and changed the design of the rocker arms from offset or cross-check to side-by-side. This significantly lowered the overall performance but achieved its other goals. The 318 became the most affordable and therefore most common V8 of the Chrysler lineup, with new camshaft designs, got as good, if not better, gas mileage than many of the 6 cylinders of its time, and with some very robust internals like the cast iron crank, would routinely see 400,000 miles, making it one of the most bulletproof engines of all time. However, just because this variant has relatively low performance doesn't mean it can't be turned easily back into a monster. The legendary High Performance 340 shares most of its anatomy with the 318. The main differences between them, besides the obvious cubic inches, are valve size and camshaft cut, things that can be easily worked back into the engine's performance. This engine series lasted from 1957 to 2002, some 45 years, survived multiple design changes, was offered in everything from a 4-door family wagon, 2-door sports car, light commercial trucks, with everything in between, and sold millions of units across multiple manufacturers and platforms around the world. From humble beginnings on a forgotten platform to one of the most recognizable engines of all time, it helped mold the automotive industry into what it is today. It truly is deserving of its legendary status, a V8 for the average Joe, with the bones of a giant killer. Now, let's introduce its counterpart, the world-renowned Slant 6, and how it came to be near unbeatable in its class. However, in order to properly explain why this engine is so remarkable, we have to go all the way back to the very beginning of motor racing itself. The first official inline 6 was introduced in 1903 by a Dutch company named Spyker. It was a T-head 8.8-liter engine with a near record-breaking 60 horsepower and a claimed top speed of 80 miles an hour. Although never officially tested, these numbers inspired others to continue with the inline configuration rather than the more spatially efficient W and V platform. Ormond Beach, or the birthplace of speed, in that same year, 1903, became the mecca for top speed inventors and drivers. This was large in part due to its hard-packed, smooth beachfront. The world-famous Napier L48 Samson, with its 15-liter, 90-horsepower inline 6, broke the world land speed record here. It went 104.6 miles an hour in 1905. The inline platform continued to dominate land speed records all the way up until 1922, when they began the trend of mounting huge W and V airplane engines inside car chassis. This monumentous change made the inline platform all but obsolete for top speed runs. However, it still had one last trick up its sleeve. In 1926, Frank Lockhart, a young Indy 500 racer, went 174 miles an hour in a tiny 91 cubic inch supercharged inline 8. And in 1928, he attempted the record in a twin-engine version of this, narrowly missing the mark, going 198.29. The record this year was set by the world-famous White Triplex, a 36-cylinder, 81-liter triple V12 aero engine that went 207.55 miles an hour, just some 9 miles an hour faster for an engine package more than 27 times its size. This proved that not only was the inline platform able to compete against the much larger V engines, but also able to create power much more efficiently. This idea would be proven time and time again over the coming decades. One such example, as we have previously discussed, was the fabulous Hudson Hornet. This world-renowned vehicle was equipped with recessed or stepped-down floors that actually wrapped around and underneath the chassis. This generated a very low center of gravity, perfect for hard cornering. Under the hood was the fabled twin H-power engine. This 308 cubic inch inline 6 motor had twin one-barrel carbs and a 4.5-inch stroke. At its height, produced 210 to 220 horsepower and 270 pound-feet of torque. Impressive even by today's standards, some 70 years later. Armed with this engineering masterpiece, Marshall Teague and the legend himself, Smokey Yunick, exploded on the NASCAR scene in 1951, absolutely demolishing its main competition, the Oldsmobile and Ford V8s. Despite having a much lower revving engine and 2 less cylinders, the Hudson won the NASCAR championship in 1951, 52, 53, and second in 54, with an overall win percentage of an astonishing 83%. The Hornet won 27 of 34 races in 52, 22 of 37 in 53, and 17 of 37 in 1954, taking first through third place in the vast majority of these, making it the single winningest race car in NASCAR history. Sadly, Hudson closed its doors in 1957 due to a sharp decline in sales, but the impact it made changed racing history forever, proving once again that the inline platform can stay competitive against the larger V8s. In the mid to late 50s, foreign companies like Simca, Volkswagen, Volvo, and even Toyota began gaining in popularity. This was large in part due to their fuel efficiency and compact body styles. Up until then, American manufacturers' main focus were full-sized, powerful vehicles, with little emphasis on gas mileage. This created a hurdle the likes of which they had never encountered before. In response to this new consumer trend, American automakers created a special division to construct the ultimate American compact, to compete against the invading imports. Chrysler, wasting no time, delegated Willem Wertmann to lead this project in 1957. This special engine project was to be a clean sheet design to replace the antiquated and bulky Flathead 6 for a much more compact platform. What they came up with was possibly the greatest engine design ever made. The distinct 30-degree from center engine block reduced the overall height from carb to pan, allowing for lower body and hood lines. Because of this angle, the water pump could be side mount or lateral offset, condensing the engine's overall length. Since the engine is slanted to one side, this not only lowered the center of gravity, but also allowed for a much longer intake and exhaust manifold. This meant the intake runners for cylinders 1 through 3 could be identically mirrored by their sister cylinders 4 through 6, making for an incredibly wide torque curve and simultaneously granting optimum fuel-to-air ratio, creating formidable fuel efficiency. This engine was to be debuted in conjunction with Chrysler's new ultimate compact, the Valiant, year starting 1960. This same year, NASCAR sanctioned a special Compact Series race event, which would involve the big three American automakers. In preparation for this race, Chrysler engineers would take an ordinary 170 Slant 6 to extraordinary heights. They gave it dome-top pistons for increased compression, a very hot camshaft, custom 4-barrel AFB carburetor, specialty-made split exhaust manifold, and the eye-grabbing 21-inch long intake. This intake was specially designed to create a ram effect at about 4 to 4,500 RPM, right where you need it coming out of the corners at Daytona. With this new package, the engine produced somewhere between 196 and 210 horsepower, numbers that rivaled much larger V8s of its time. This project would come to be known around the world as the Hyperpack. Come race day, Daytona Beach, January 31st, 1960. 8 different manufacturers came to compete: Chrysler, Ford, Chevrolet, Volvo, Simca, Studebaker, Morris, and AMC. The small glimmer of hope in their eyes soon faded as they watched in horror as the Valiant completely decimated any competition in its way. With an average speed of over 88 miles an hour in the combination course, all 7 Valiants that entered the race finished 1st through 7th place, absolutely embarrassing the other manufacturers. Even in the long speedway course, where their larger engine displacement should have given them some semblance of an advantage, the small 170 cubic inch Valiant finished 1st through 3rd with an average of over 122 miles an hour. In order to save face for the other manufacturers, NASCAR downplayed these results and canceled any future compact events. But for one brief shining moment, the Slant 6 sat alone atop the altar of racing and ruled with an iron fist. The Slant 6 wasn't just a high-performing bulletproof engine. Because of the gas crisis in the early 70s, Chrysler sanctioned a special lightweight, fuel-efficient feather duster in 1976. This vehicle only weighed 2,700 pounds and obtained 36 miles to the gallon, which still holds the record for its class to this day. As time went on, the desire for performance upgrades from motorists grew stronger than ever. With help from people like Jack Clifford and later Doug Dutra, there was not only a product line, but also an in-depth understanding of these engines, helping rocket it from just another engine lost to time to the legendary symbol it is today. The Slant 6 was produced from 1959 to 2000 and was offered in cars, trucks, buses, and even agricultural equipment. Millions of these engines were sold to every corner around the world, influencing entire generations to carry on the torch. From the very beginning of motor racing itself, the inline platform has fought an uphill battle, consistently challenging what we are told is superior, and consistently rising to and overcoming those challenges. Despite all odds, this platform is still used in motor racing today, still changing minds, still breaking records, and still taking the larger opponents head on. The Slant 6 has truly earned its hard-fought place in racing history. The engine that no one suspects, with the performance no one can deny.
Here he comes, racing to the checkered flag.
So, without further ado, let's jump right in. First up, the 225 Slant 6. Pretty impressive numbers for a half-century-old 6-cylinder. Next up, the 318. In our previous videos, these two have always been extremely close, and once again they did not disappoint, as the gap separating them was never more than a few milliseconds, and in one particular portion, they were actually identical. So now that we have a solid baseline, we can compare and contrast what these numbers mean and what they translate to in real-world driving situations. First up, the 60-foot jump. This test is meant to highlight the engine's torque characteristics at low RPM, before the engine has had a chance to reach peak power. Theoretically, this is where the Slant 6 should have an advantage due to its longer crankshaft and its greater volumetric efficiency at low to mid RPM. However, as we see here, the little V8 that could impressively puts up an almost identical 2.75 seconds, demonstrating that its 9.1 compression over the 7.5 Slant 6 can help overcome its pitfalls on the bottom end, a very well designed V8. Next up, the 0 to 60 and the 8th mile. These tests are meant to highlight the engine's mid to high RPM performance, your basic, let's get on the freeway test. This is where the 318 shorter intake runner, V configuration, and larger cubic inches begin to hit its optimal power band with the increased RPMs. However, not to be outdone, this is also where the Slant 6 engineering shines its brightest. The intake length and plenum volume were specifically designed in conjunction with its valve timing and reverse flow cylinder head. This creates the Slant 6 secret weapon, sonic resonance. We will dive more into this in upcoming videos, but for now, let's just say its volumetric efficiency is off the charts. Both of these examples are directly reflected by these results, as they each climb past the identical 60-foot jump times and into the mid to high RPM range. The Slant 6 flexes its engineered advantage of sonic resonance to actually increase the gap between them in the 0 to 60 test. Then, as the RPMs climb higher in the 8th mile, the 318's larger cubic inch displacement and increased airflow close the gap to essentially identical numbers once again. The 1,000-foot test is where things get very interesting. The 1,000-foot is meant to test a vehicle's all-around performance. It is 320 feet shorter than the quarter. This shorter distance still allows for peak RPM to be reached, but not for an extended period of time like in the quarter mile. This gives you a better feel for the engine's all-around performance and not just peak power. This obviously does not apply to purpose-built race cars. It's more of a generalization for most out-of-the-box factory vehicles. Incredibly, both of these vehicles hit identical numbers. Now hold on, all you 318 fans out there. There is a legitimate reason for this, and no, it's not sandbagging. Both of these engines have different redline points. The V8 at 5200 and the Slant 6 at 4000, which means they have very different shift placement. As both Dusters move past the 60-foot jump, the Slant 6 second gear shift is placed around 45 miles an hour at 7.4 seconds, whereas the 318 second gear is placed at about 50 miles an hour and a full second later, 8.50. This means as they approach the 1,000-foot mark, the Slant 6 has been in its optimal power band for quite some time, and the 318 has just barely begun to touch it. This would suggest, as the race continues, the 318 would stay in its optimum power band and increase the gap as the Slant 6 moves out of its own, which is exactly what we see with the results of the quarter mile. The extra 320 feet past the 1,000-foot mark allowed the V8 to stay in the upper RPM range for an extended period of time and reach its maximum power output all the way through the finish line. This head-to-head battle epitomizes the rivalry between these two camps, each showcasing their individual strengths, and neither side backing down to the very end. Once again, I'd like to thank you all for the continued and growing support. If you liked this video and would like to see more, please help us hit that 1,000 subscriber mark. Like this video and comment on the outcome, your favorite part, or what you would like to see next. Thanks for watching.